Question 5.2 is your parabolas and stuff, but we're starting to introduce some calculus. So I'm going to try and go through this slowly so you guys can understand. Okay, so 5.2 says, sketched below are the graphs of k of x is equal to ax squared plus bx plus c, so that's our parabola, and h of x, which is negative 2x plus 4, so that's just a straight line graph. Graph k, the parabola, has a turning point at negative 1 and 18. S is the x-intercept of both h and k. So over here, they intersect, and it's the x-intercept. And graphs h and k also intersect at t. Okay, so there are 2 points that these two graphs intersect with each other. 5.2.1 says calculate the coordinates of S. Okay, so you might want to try and use point of intersection, but this is an unknown equation, so we can't use that. So we have to use our h of x. Remember, it's the x-intercept, so y equals 0. So negative 2x plus 4, which is our graph function, the linear function, is equal to 0. Which means that negative 2x is equal to negative 4. So x equals 2. So S sits at 2 and 0. Okay, so let's fill that in on the graph. 2, 0. 5.2.2 says determine the equation of k in the form y equals ax plus p squared plus q. Okay, so this is the turning point formula. Remember, guys, this is your x value of the turning point, and that's the y value. And we've been given the turning point. Okay, it's negative 1 and 18. So we know that y equals ax plus 1, remember the sign changes in the brackets, plus 18. Okay, so now we've got this, all we have to do is substitute another point into the graph, and we've just worked out the coordinates of S, it's the x-intercept. So 0 equals a into 2 plus 1 squared plus 18. So keep on going. I'm going to first simplify the brackets. So 2 plus 1 is 3, squared is 9. So that means that 9a is equal to negative 18, and therefore a is equal to negative 2. So our parabola has the equation of negative 2x plus 1 all squared plus 18. Okay. Next question, 5.2.3. If k of x is equal to, okay, so basically this equation is just this one expanded, okay. Determine the coordinates of t. Now t, if we take a look, was the other intersection, okay. So guys, the moment you have a point of intersection, you equate the two equations. So our functions are h and k, so you make k of x equal to h of x. Okay, so easy stuff. They've given you a nice simplified version of k of x. So negative 2x squared minus 4x plus 16 is equal to, and that's the parabola equation, so the straight line equation was negative 2x plus 4. Negative 2x plus 4. And obviously, guys, because this is a quadratic function, you're going to get two different values because these graphs intersect at two different areas. So you should get x equals 2 and then another x value for t. So let's go and have a look. Negative 2x squared minus 4x plus 2x is negative 2x, and 16 minus 4 is 12. Okay. So now to simplify this equation, I'm going to divide by negative 2. So we get x squared plus x minus 6 equals 0. Okay. Now, easy peasy, x plus 3, x minus 2 is equal to 0. And therefore, x is equal to negative 3, or x is equal to 2. And remember, this is for point S because it sits at 2, 0. So t will sit at x equals negative 3, But remember, guys, you need to find the y value. So substitute it back into a formula. I'm going to substitute it back into our linear equation because that makes it so much easier. So for t, y is equal to negative 2 times negative 3, which is this x value here, plus 4. So that's going to give us 6 plus 4 is 10. So t sits at negative 3 and 10. Okay, let's go fill that in on our graph. Negative 3 and 10. Okay. So now, 5.2.4 says determine the values of x for which k of x, which was, I think, our parabola, parabola, is less than the linear function. So what does that mean? It means if you go and look at your graph, you want to see where the parabola, if you follow your graph from left to right, where the parabola sits below the linear function, okay? So if you look here, this is where they intersect. And that was at negative 3. And they also intersect at 2, okay? So between negative 3 and 2, we've got the parabola sitting above the linear function, okay? So that doesn't help us. We need to have the parabola sitting below the linear function. If you look over here, our linear function over here sits above the parabola. And over here as well, the linear function sits above the parabola. So x needs to be less than negative 3, less than negative 3, and x needs to be greater than 2. Okay, and we don't put in equals because there was no equals over here. We don't include the points of intersection. It's just less than or greater than. Okay, so that's where the parabola sits above or below the linear function. 5.2.5 says it is further given that k, which is the parabola, is the graph of g prime of x. Okay, so we've been given that there's some function g which will be a cubic. Because remember, if you have a parabola, which is a quadratic, it's in x squared. If it's the derivative, which is g prime of x, it means that the original function is going to be a cubic in terms of x cubed. Okay, so A, for which values of x will the graph of g be concave up? Okay, so remember, guys, you start off with your cubic function in terms of x cubed. And then you derive and you get in terms of x squared, which is going to give us our parabola, or whichever way the parabola goes. And then you derive again, and you're going to get a linear function in terms of x, okay? So if this is the original function in terms of x cubed, g prime of x is going to be in terms of x squared, and g double prime of x is going to be just in terms of x. Now remember, guys, first derivative gives us the gradient of both the function and the tangent at that point. It gives us an indication also of whether it's increasing or decreasing. But g double prime of x gives us an indication of the concavity. Okay, so when you're looking at concavity, you're looking for g prime of x. Okay, so if we're given that k is g prime of x, okay, we're looking, double prime of x. So k was given to us as negative 2x squared minus 4x plus 16. So here, negative 2x squared minus 4x plus 16. Okay, so g prime of x, you simply differentiate this equation over here. So we're going to get negative 4x minus 4. So now for concavity, guys, where g prime of x, double prime of x, is greater than 0, then it's concave up. when g double prime of x is less than 0, it's concave down. Okay, and we're trying to find concave up. So we make this negative 4x minus 4 greater than 0, where it's positive. So negative 4x is greater than 4. And now if we divide by a negative, the inequality swaps sides. So we get x is less than negative 1. Okay, so for every value below negative 1 of x, the original function is going to be concave up. Okay. So here we go. It says sketch the graph of g, the original function, remember, in the terms of x cubed, showing clearly the x values of the turning points and the point of inflection. Okay, so what is the point of inflection? It is the change in concavity. Okay, so it's where it changes from being concave down to concave up or vice versa. So now remember, here we found that x needs to be less than negative 1 to be concave up. So from negative 1 onwards that way, it is concave up. Okay, and then from negative 1 onwards that way, it's going to be concave down. That's one thing. So we know that the point of inflection, guys, sits at negative 1, where x equals negative 1. Okay. Now, how do we find the turning points? Remember, guys, we don't actually need this graph here, so I'm going to take it away. Remember, you're going to have a graph that looks like this. At the turning points, if you drew a tangent to the turning point and you found the gradient there, remember, it is equal to 0 because it is a flat horizontal line, 0 gradient. So what gives us an indication of the gradient? It's g prime of x. So if we look at our original graph, remember we were given that this parabola, let me come and get rid of this mess, negative 3, 10, and 2, 0. Okay, so we know that this point here is negative 3 and 10, and s sits at 2 and 0. If we were given that this parabola is the first derivative, remember this is g prime of x, where this equals 0, we are going to get the turning points of g of x. So we found it. At x equals 2 and x equals negative 3 is where the turning points. So here, turning points at x equals 2 and x equals negative 3. Okay, so when you draw your function, you're going to have to indicate these values. Okay, so at x equals 2, we're going to have a turning point. At x equals negative 1, we're going to have the point of inflection. And at x equals negative 3, we're going to have another turning point. Okay, so here we're going to have it come through, turning point, point of inflection at negative 1, and another turning point at 2. Okay, make sure you draw it a bit more smoothly. Okay, and point of inflection at negative 1. So remember, it goes from being concave up to concave down at negative 1. Okay, guys? So remember, just tips and tricks for your cubic functions, guys. Cubic function, the first derivative is going to give you an idea of the gradient and whether it's increasing or decreasing. The second derivative, g double prime of x, is going to give you an idea of the concavity. Okay, so where the second derivative is greater than 0, it's going to be concave up. And when it's less than 0, it's going to be concave down. So make sure you remember how to draw your cubic functions. Okay, so that is the end of this question.